stars could potentially be split in two by relativistic blades. This is the claim of a study published in September on the preprint Arxiv database. According to the study, a number of blades splitting the star could explain some of the brightest explosions in the universe. The research authors, based at the Center for Cosmology and Particle Physics at New York University, detailed their findings in a paper not yet peer-reviewed. The researchers were investigating the origin of a specific type of gamma-ray burst GURB. GURBs are among the most powerful bursts in the sky, but typically occur at very distant distances. This means we can only perceive them as brief yet intense bursts of excess gamma-ray radiation. Only a few objects are known to produce the energy required to generate GURBs. Therefore, most astrophysicists assume that black holes or magnetars are involved in such extreme events as tearing apart stars. However, astronomers still struggle to explain why some GURBs fade very slowly. In the new study, the authors argue that the remaining GURBs might occur when some massive stars, similar to our Sun, die. The core of the dying star then collapses, forming a neutron star, an ultra-dense neutron ball surrounded by heavy layers of hydrogen and helium. This neutron star can acquire an extremely strong magnetic field through compression and rapid rotation. This transforms the neutron star into a magnetar, housing the strongest magnetic field in the universe. The newly born magnetar is surrounded by the chaos of the collapsing star. Eventually, its own gravitational pull draws the remnants of the parent star into it. But intense radiation and the magnetic field make the plasma spin. In previous research, astronomers concluded that within this whirlwind, a jet forms along the axis of the magnetar's rotation, penetrating the dying star. However, the authors of the new study realized that the magnetar's magnetic field could also emit powerful bursts of radiation along the equator. Formed by the extreme centrifugal force of the spinning star, this radiation burst forms a blade, like plasma moving outward through the star at almost the speed of light, carrying greater energy than a supernova explosion. The relativistic blade could perfectly split the star in two, cleaving it in half as it exits, the research authors found. The powerful plasma blade then travels several times the radius of the original star, before finally losing its steam. This last aspect is claimed to potentially explain some longer-lasting GURBs. Meanwhile, the fate of the star that becomes the victim is already determined. As the plasma blade swiftly cuts through the star, it attracts more material that ultimately merges with the blade as it exits the stellar body. The blade also causes instability within the star itself, ultimately leading to its destruction. For the study, the researchers only demonstrated that the relativistic blade could explain these GURBs. For the next steps, the researchers plan to study how the blade evolves over time, and how exactly the death of the star occurs. This will allow them to identify the key characteristics of this type of explosion, and determine whether some previously observed GURB phenomena can be explained by this new model. Source: Live Science.